So students, let us look at the next section. This section contains paragraph type questions. So we have 3 paragraphs, and based on each paragraph, we have 3 questions. Each of these questions has one or more than one option correct. So let's start with the first paragraph for question number 27, 28 and 29. So we have been given a reaction sequence for the preparation of alpha amino acid. So let us look at question number 27. So we have a negative charge over nitrogen and we have a substrate given to us which has a leaving group present. So this negative charge over nitrogen can attack on this carbon and make this Br group leave. So which will lead to the formation of P. So we can probably draw the structure of P. Now students, it is allowed to react with NaOET. So this NaOET will not lead to transesterification as the ester form will be the same. So next it will go and extract the acidic hydrogen on the alpha methylene group. So it will attack here and generate a nucleophile. Now this nucleophile is allowed to react with some certain reagent which is labeled as X and which forms Q. And on the hydrolysis of the compound Q, we have CO2 organic compound E, and then we have a amino acid which is labeled as R. So we have been given some information about the product R, which is the alpha amino acid. So examiner tells us that if R is methionine having formula this, then X may be. So students, if we look at the structure of R very carefully, we have a sulfur atom present, and if we look at options D, option D can directly be eliminated as there is no sulfur, and then we can also probably eliminate the option B as there is no leaving group or an electrophilic site present inside the molecule. So all that is left to check is options A and option C. So in option C, the nucleophile generated can attack and replace this Cl- ion, and in option A, the nucleophile can attack this carbonyl carbon. So let us start with option C first. So if this carbon ion attacks, the structure given in option C will have this structure. So this negative charge can come and attack on this carbon and make this Cl- leave. It will lead to the formation of this structure, PH N followed by SCH3. So now let's call this as Q. Now when this is subjected to hydrolysis, firstly in the basic medium is going to hydrolyze the entire structure and convert this to an amine, convert both of these to carboxylate ions. And when the mixture is further acidified using HCl and then heated, this will probably acidify the carboxylate ions, convert this to amine. And since the structure form will be a geminal dicarboxylic acid, on heating, it will undergo the loss of CO2. So this is where the CO2 is coming from. So let's try and draw the hydrolyzed products. So we'll have phthalic acid, we'll have a geminal dicarboxylic acid, and this on heating will undergo loss of a CO2 molecule to give us an alpha amino acid, which seems to be methionine. So students, we can see that the correct answer for this question is option C. Let us look at question number 28. In question number 28, the examiner is telling us if R is methionine, select the correct statement about E. So students, previously we had seen that the compound E is phthalic acid. So the compound E under consideration is phthalic acid, PH, COH and COH. So it is allowed to react with ethylene glycol. So we have ethylene glycol, CH2OH, CH2OH. Examiner seems to be interested in the polymerization of these two species. So students, when polymerized, they give us glyptyl. So we have to mark option B as the correct answer to our question. Let us look at the last question for this paragraph. If X is 1 bromo 2 methyl propane. So we have been given the structure of X. X is 1 bromo 2 methyl propane. So we had seen the nucleophile which was generated on reaction of P with A. So let's draw the structure directly. So now this nucleophile will attack and make this Br group leave, which will lead to the formation of this species. And when it is further subjected to hydrolysis, the same thing will happen. This will get converted into an amine here. This will convert it into carboxylic acids, and on heating, this geminal dicarboxylic acid will undergo decarboxylation. So we are going to have NH2 from here. One of these COH will leave in the form of CO2 and will have the structure of the alpha amino acid as this. Now this is the structure of leucine. So let us look at question number 29 now. We have to select the incorrect statement about the product R. Option A, it is an essential amino acid. Students, we had seen that this is leucine and it is an essential amino acid. So this statement is correct. It is a non-essential amino acid. This statement is incorrect. It is proline. This statement is also incorrect, students. Proline has a cyclic structure. It has no chiral carbon. It has a chiral carbon. This statement is also incorrect. Students, we have to select options B, C and D as the correct answer to our question. Let us look at the next paragraph. Consider the given reaction sequence. 2 moles of compound P react with Cn minus in presence of ETOH to form Q. Q undergoes oxidation to form R, and R undergoes hydrolysis of some sorts to form S. So compound P having formula C7H6O. C7H6O, the DU is equal to 5. Does not reduce Fehling solution while it reduces the Tollens reagent. So we could have a aromatic CHO group. Compound P does not give iodoform test. It is not a methyl ketone, but it is disproportionate in basic medium. So based on these informations, we can see that the compound under consideration is benzaldehyde. So we have the structure of P as PHCHO. So now when benzaldehyde is allowed to react with ethanolic Cn-, we have benzoin condensation. So PHCHO in presence of Cn- ETOH, it undergoes benzoin condensation to form benzoin. So we have PH, C double bond O, CHOH, PH. Now this benzoin is allowed to undergo oxidation. So the alcohol group will get oxidized to a ketone. So we'll have PH, CO, CO, PH. So this is called as benzyl. And in the last step, this will lead to benzyl benzylic acid rearrangement. So 1 OH minus 2 H plus is going to form PH, and another pH at the bottom. So let us try and label these molecules. So this was P, benzoin was Q, benzoin on oxidation forms benzyl, benzyl was R, and the compound S is benzylic acid. So we have to comment on the structures of R and S. So benzyl and benzylic acid are correctly represented in the B option. Let us look at the next question. If P reacts with excess of acetic anhydride in presence of sodium acetate at 140 degrees C and after hydrolysis gives compound T, the correct statement about T is R. So let's try and figure out what the product T is. So we have benzaldehyde, which is allowed to undergo Perkin condensation with acetic anhydride in presence of sodium acetate. So it will lead to the formation of cinnamic acid, which is the compound T. Now, if you look at the options, we have to mark the correct statements. So if you look at the options, it has 5 degrees of unsaturation. The du of this compound is equal to 6. 4 in the benzene ring, 1 for the double bond and 1 for the double bond O. So this statement is incorrect. It has a carboxylic group, this statement is correct. It has an aldehyde group, this statement is incorrect. It has an acid group. It is an aromatic compound, this statement is also correct. So students, since we have to mark correct statements for this question, we have to mark option B and option D as the correct answer to our question. Moving on ahead to the next question.